Okay, so this next video what we'll do is find some exact values for some given situations. So you'll notice that all the angles that are in here, 105 isn't one of our special angles that we can find exact values. This 165 isn't. Pi over 12 is not. 5 pi over 12 is not either. Recall our special angles are the quadrantal ones, right? So those are the special ones, 30, 45, and 60 degrees, right? And then of course this is pi over 6, pi over 4, and pi over 3 respectively, and pi over 2. So we're used to handling things with 2s, 3s, 4s, and 6s in the denominator. Those represent common angles, or 30, 45, 60, and then things like 90, 180, and whatever with pi over 2. So none of these, except for right there, right, have the things where we can use our unit circle or use our knowledge of some common special angles to find the exact value. So this is where this plays a role. So to find the cosine of 105, I just need to think, do I want to rewrite 105 as a sum or a difference? What two angles add up to 105? And preferably they're nice and special, or which one subtract? And if you look real closely, if I take 60 and 45, right, we know that that is a way to rewrite the cosine of 105, to rewrite it as 60 plus 45. So this means we're now talking about the cosine of 60 plus 45, and we have our sum, right? It's up here at the top. We have our sum in play now. So we can use this identity to rewrite this. So we get the cosine of 60, the cosine of 45, and then we're going to subtract the sine of 60 and the sine of 45 as I run into that other one. All right, and then of course break out your unit circle. Hopefully you've got these committed to memory, right? What is the cosine of 160, or excuse me, of 60 degrees? Well, that would be 1/2, right? And then what's the cosine of 45? That's the square root of 2 over 2. The sine of 60 is the square root of 3 over 2, and the sine of 45 is the square root of 2 over 2. So just doing the math, we get the square root of 2 over 4 minus, that'll be the square root of 6 over 4. And if we clean that up, perhaps this is a way to look in the back of the book. There's the square root of 2 minus the square root of 6 all over 4. And so there is our exact value for the cosine of 105 degrees is the square root of 2 square root of 6 all over 4. So there's our exact value. Same thing for the cosine of 165. We got to come up with a couple of things that add up to it. I've already done addition, so how about we do subtraction? All right, and I believe 165, if we worked with this is basically, let's see here, what can I do? 120. This is, oops, I'm trying to have a tough time subtracting. 35. Yeah, this is 180. Nope, I think all I can get is a sum. All right, so I'm thinking 150 plus or 120 plus 45. That's the only thing I can come up with. So sorry, maybe I should have done that one as a subtraction. So this basically means that this is the cosine of 120 plus 45. And so I'm going to basically use the same guy here. So we get the cosine of 120, the cosine of 45, minus the sine of 120, and the sine of 45. Let me sneak that in there. So the cosine of 120, that's in quad number 2. All right, and it basically has the same thing as cosine 60, but it's negative. So we get negative 1/2. That's the square root of 2 over 2. The sine of 120 is a positive square root of 3 over 2, and the sine of 45 is square root of 2 over 2. And so this is negative square roots of 2 all over 4 minus the square root of 6 all over 4. All right, so the cosine of 165 is negative square roots of 2, negative square roots of 6 all over 4. So there would be the exact value for that guy. All right, and I can't come up with a sum or a difference on that one. I think the next one, I've already kind of prepared that one. So cosine of pi over 12. One of our strategies is to basically convert this to degrees and then use our knowledge of degrees. But what I'd like to do is get you guys used to working in radians and pies. So we have a denominator of 12. So what I have is some combination, right, of 2, 6, 4, and 3. There's probably several of them, but just to save us some time, we can find that if I take pi over 3 and subtract pi over 4, right, this becomes 4 pi over 12 minus 3 pi over 12, which is pi over 12. So the cosine of pi over 12 becomes the cosine of pi over 3 minus the cosine of pi over 4. And now I can use that subtraction identity now. All right, and so using that subtraction identity, this becomes the cosine of pi over 3, the cosine of pi over 4, minus the sine of pi over 3, and the sine of pi over 4. Okay, and so essentially what we have is the same thing up here. Pi over 12 and 105 are essentially the same, but here we're working on it in radian mode, and here I'm working on it, or excuse me, it looks very similar, but pi over 3, let me make sure I got that right. Yeah, pi over 3 corresponds to a 60-degree reference, so the cosine is 1/2. This we know to be the square root of 2 over 2. We're adding there, adding the sine of pi over 3 is square root of 3 over 2, and then the sine of pi over 4 is the square root of 2 over 2. Sorry about that. All right, and so we end up getting, these are not the same, they're different. Okay, I think this is 15 degrees if I'm not mistaken. So we end up with the square root of 2 over 4 plus the square root of 6 over 4. So the cosine of pi over 12 is the square root of 2 plus the square root of 6 over 4. So it's different than the cosine of 105, so that was a false statement. I believe it's 15 degrees, okay? But we're working in terms of pi's. Alrighty, so there you go. We found an exact value by creating a sum, in this case a difference, and then using the cosine of the difference. Last one, if you look at this one, lots of ways to approach it, but we're adding cosines and sines. So this is basically our identity of the subtraction in reverse. All right, and so if we basically rewrite this in terms of that, this becomes the cosine of 5 pi over 12 minus pi over 4. All right, and we're still dealing with this angle that we're not familiar with, but if we just do the subtraction, I think we find we have a common denominator of 12, so this becomes 3 pi over 12. So this is the cosine of 2 pi over 12, which is the cosine of pi over 6. All right, and so that corresponds with the 30-degree reference. So what do we know about the cosine of pi over 6? That's the square root of 3 over 2. So this expression, right, equals the square root of 3 over 2 via the cosine of a difference, and then using our subtraction skills, and then our unit circle, or hopefully you guys have the big ones memorized at this point, whether they're in radian or degree mode. So there's your exact values for finding some things of new functions. Again, it's going to be, what's challenging for you guys is just finding the different sums and the different differences. And usually when you have a pi over 12, you know, you're probably looking at some combination of pi over 3, pi over 4, or pi over 6. You just have to kind of work with that. I think you guys will get better as you continue to use it, and I'll continue to show you some examples. So for pi over 12 is definitely pi over 3, take away pi over 4. 5 pi over 12 is basically, you know, we'll work with that combination a little bit later because I didn't need it at this time. Alrighty, so see you guys in the next video where we continue to find some exact values under certain situations.